Hey, Jameson here, and in this video we're going to compare Firebase and SQL. And what is Firebase, first of all? Well, Firebase is a platform available at console.firebase.google.com, and they have generous Spark plans available if you want to check that out. I have no affiliation with them, I just really like the product, I highly recommend it. And its flagship database is called Cloud Firestore. And this video will compare Cloud Firestore with SQL, because it doesn't really make any sense to compare Firebase with SQL because Firebase is an entire platform. So, I was doing research for this video, and the most common search term for this sort of thing is Firebase versus SQL, but that doesn't even make any sense. We're going to be comparing Firestore versus SQL because those are both databases and they can be properly compared. So how does Firestore store data? Well, it uses collections and documents to store data, and kind of what this looks like is a collection is simply a name for something. It's only used as a path to a document, and a document is essentially just a JSON object. So essentially, Firestore is collections and documents. In other words, it is just paths to JSON objects. And that's basically it. That's why so many people like it. It is extremely simple. And that JSON object, if you're not familiar, has fields in it like, you could have first name Fred, last name Jones. You can store numbers in there. You can store timestamps. All sorts of things you can store in there that you can store instead of regular JSON objects. Like I was saying earlier, a collection is really a path to a document, but to be more specific, it's a path to one or more documents. So you can have many different documents inside of a single collection. And in fact, it always has this relationship of documents can only be stored under collections. So it always goes collection, document, and those documents can even have collections themselves, but it's really kind of just a path thing. A document is only ever stored at a particular path, and in Firestore's case, the path must always go collection, document, collection, document. It always alternates like that. You're never going to have two collections in a row, and you're never going to have two documents in a row. So to show you this more visually, you can have two collections side by side at the root level, each storing their own documents, but you can also have sub-collections under either one of those. So to be even more specific, I'll give you an example of how my site works, jamesonsaunders.com. This is kind of how the structure works. We have users, which are people who sign up for an account. They have an email and a password and a display name and things like that. And when they create an account, I create a user document for them. That's the top left here. And then as those users interact with my site, I might tag them in certain ways, like, oh, this user has visited this page, so I'll give them a tag so that I know that they've done that, and I know how to email them automatically and things like that. Or if they purchase a product, which I call a subscription because I offer payment plans, and so that's why they're called subscriptions. So if they buy a subscription, I might create a subscription object under them, showing them that, okay, you've purchased this product and now here it is in your user interface. So that's kind of what these documents are for. You can see that users is its own collection with its own documents, but then those documents can have their own collections, which in turn can have their own documents. So this nested structure is really critical to understand. It's not just one level, it's not linear like that. It is recursive in a sense where a collection can have documents, which can have more collections, and it always follows that path: collection, document, collection, document. All right, so we finished talking about Firestore. Things are stored as collections and documents in this nested way. And then what is SQL? Well, SQL stands for Structured Query Language, and what we're going to be comparing here with Firestore is actually a SQL database, not the language itself. That doesn't really make any sense. SQL is just a language, but what people are trying to understand here is the difference between Firestore, the database, and a SQL database. So now the question is, how does a SQL database store data? Well, a SQL database is all about tables. All right, columns and rows. So table 1, table 2. Let's take a look at the example we did earlier with Firestore regarding my website. Let's take a look at that in a like how I might do it in a SQL context. So each user is pretty simple. They're just stored one row at a time. Each of them has an ID starting at 0, counts up from there. It's called an auto increment ID. So that's really how SQL works, is you can add new entries and it just starts counting up. Okay, this is entry number 0, 1, 2, 3, and that ID is used to identify each row uniquely. It's called a unique identifier, or a primary key is another word for it. And then the other columns are just the data for each row, like the first name, the last name, and their email. So there's one per user. Pretty straightforward, but then where things start getting a little tricky is when we're trying to represent a relationship between users and subscriptions. So what you would have to do in this case is called a many-to-one relationship. And what I mean by that is many different subscriptions can belong to a single user. And the way that you have to represent that relationship inside of SQL is each row for each subscription needs to have an identifier for which user this belongs to. So that very last column, the user, that's which user ID this subscription belongs to. And even though this example is very simple, hopefully you can see how this sort of thing can really blow up on you if you have a lot of relationships between a lot of different tables. Then you have to write a lot of queries using SQL in order to get different things, like get the subscriptions for a user. You have to write queries to get all those different things. Whereas in Firestore, things are kind of stored a little bit more straightforward. You just request, that user's subscriptions because they're organized in a nested way. So in my opinion, it's a lot more straightforward to get data from a Firestore database, or a NoSQL database as it is commonly referred to. Anyways, that is the difference for you in summary. Cloud Firestore uses documents and collections in a nested fashion to store data, and a SQL database uses tables to store its data. And that's it. I'd appreciate it if you leave a like on the video as well as subscribe. It really helps me out with the YouTube algorithm. And hopefully you're looking forward to more videos from me as well. So thanks for watching, and I'll see you in the next video.